Data analytics and artificial intelligence are today the most important platforms to support the growth of any organization. In this area, DataRobot is a strategic partner offering to their customers expert services that include data management, data visualization, predictive analytics, business intelligence, data science, data security, and cloud computing. We have helped customers like HSBC, Sanofi, and Bimbo to generate significant savings in their business, identifying new growth opportunities and reducing risk through data analytical platforms that improve their decision-making, transforming companies to be more informed with data-driven decisions. DataRobot is a partner of the best data analytics technologies: Power BI, ClickSense, Tableau, Snowflake, Databricks, Synapse, Azure Machine Learning, etc. Staff your data analytics backlog in a nearshore schema with a certified team of consultants. DataRobot, release the power of data.
Hello, I'm Dr. Beverly Wright, and welcome to Tag Data Talk. With us today, we have Chad Harness, Director of Technical Enablement at DataRobot, and he's talking to us about successfully leveraging AutoML to solve complex problems. Welcome to the show, Chad.
Thank you very much.
Awesome. Well, let's start off with a little background. Tell us, why are you so cool?
Well, my wife and kids would say I'm not, and they know me best, but I'm on this show. So thank you for having me. That's pretty cool. And I would say that the reason I'm here, and I guess what qualifies me to talk about AutoML, is that I've been a data scientist for 15 years. My background is in statistics. In machine learning and data science at NC State and at Berkeley. And I've been at a company called DataRobot for the past little over 4 years. And that's what we do. We do AutoML. So that's why I'm cool. That's why I'm here.
I love it. And I am so glad, and it's so refreshing to hear someone from stats background. It's like the lost art of stats, Where did it go? It got eaten up by computer science or something.
It's still here. It's still here.
Yeah, I love it. I love it. I love it. Let's create the black box, right? So before we start digging into successfully leveraging AutoML, can you, for our guests or our listeners, can you help describe AutoML to a lay business person?
Yeah, absolutely. So AutoML is kind of the automation of certain steps in the model building lifecycle, right? So if the model building lifecycle starts with problem framing and idea generation and kind of ends with the delivery of the model, AutoML is going to take some of those steps in there and actually automate them. Typically, from the kind of feature engineering and some of the data quality check out to the deployment aspects of it, but then also a little bit in some of the delivery as well.
Okay. So if you think about, it's 7:35 and I haven't had dinner. And so I kind of want something like cake right now. So if you think about making a cake, you go out to the garden and you gather, I guess it's wheat and stuff. I've never actually made a cake from scratch, but you get the raw ingredients, and that's kind of like coding. And then maybe you get a box, but you still have to add things to it, mix it up. And maybe that's like a GUI. And then you have, you go to the bakery and you choose the right cake. And maybe that's more AutoML in a sense, but there's still some manual processing to it. How would you parallel that to cakes?
To cakes. Oh, that's a tough one. So, I would say that AutoML is a little bit like a very well prepared meal that somebody delivers to your house.
Okay.
Right. If you're a consumer, you probably shouldn't eat it if you don't know what went into it.
Exactly.
Right. But you've got a lot going on in your life, right? Like your focus, for most of us, is typically not on like, what is the meal that I'm creating tonight? You kind of just want to do that and fuel the rest of your life, right?
Right.
So that's where AutoML comes in, in data science, because you definitely need to make sure that what you're getting is good in quality, but it's going to really speed up and allow you to focus on other areas. So the areas that you should be focusing on are on value creation, right? On actually focusing on the areas that add the most value to the process and letting the AutoML kind of take care of a lot of what's in between. It can also really speed up your life, right? Or speed up your process, because it's just another layer of abstraction at the end of the day. It's not, something foreign we all kind of use scikit-learn. We all use TensorFlow. Very few people are kind of spinning up, their own like bytecode
No.
interpreter.
Why bother? Right. I mean, it's there. So, you're gonna, like, if you're doing a cluster, you're gonna be looking at Euclidean distances. You're gonna be throwing those variables in. If you're doing any kind of predictive model, there's gonna be a Y,
Yep.
or if it's multivariate, there's gonna be Ys and there are gonna be X's. And so AutoML, in a sense, sort of expedites that process
Yep.
and goes through those steps, right?
Absolutely.
So how do these, the tools like DataRobot, not necessarily only DataRobot, but
Yeah.
like that one, how do these tools tend to work? What does it look like from a user standpoint?
Yeah, so that's another great question, and and you're right to point out there are actually a lot of different AutoML tools, and they all kind of maybe focus on certain areas, right? Some maybe do a little earlier in the stack, some a little bit later, some more broad. But the way that they work is you typically just kind of need to get your data into, let's call it like an ML ready or analytics ready form, right?
Mm-hmm.
So like one row is a unit of observation. Each column is an attribute. For tabular, with image, maybe you need your images formatted a certain way, or you need like all your documents. They don't have to be like perfectly clean, but it's something that you need to be able to feed to a model, right?
Mm-hmm. Mm-hmm.
So an AutoML won't necessarily, in a lot of cases, get you to that point. You're not going to get yourself to that point, but it will like allow you to like upload it, bring it into something, and test a whole bunch of different feature engineering approaches, a whole bunch of different hyperparameter optimizations, a whole bunch of different modeling models that you can do with it. It'll do all that really quickly for you and do all of your kind of validation, surface all that validation automatically for you. It may even make it a lot easier to deploy the model, like maybe just pressing a button and like your model's deployed somewhere, or getting that executable, right? The deployable model that you can then drop into whatever ecosystem that you're in. So that's kind of how AutoML works a little bit more under the hood.
Yeah, gotcha. And it sounds like, and from my experience, the data engineering part is not for the weak at heart, especially when you're dealing with AutoML, because you really, really need that strong data prep. Is that right? Would you describe it that way? But I know you mentioned also that you can use AutoML for feature engineering. So tell us about that dance.
Yeah. So
it's very iterative, right?
It is. And that's really, I think, where a lot of the power of AutoML comes in, because if for those of us that have practiced data science for a long time, right, we know that it's a very long process, right? Data science and a model building process is actually fundamentally value subtractive. You're not adding any value to your organization by doing all that stuff, right? It only kind of comes at the end, and also you're finding out a lot as you go, right? So there's a lot of iteration, right? To your point, as you're going along, AutoML makes it really easy to do that really quickly, right? So it's not easy to kind of do the data prep and automate a lot of that, but you can automate, for example, translating features into a very machine learning form, right? Because machine learning models only understand numbers at the end of the day.
Exactly. They don't know the context.
That's right. They don't know the context at all. And so an AutoML tool can actually really expedite that. Now, it's actually not that hard to do a lot of that, with code, but it can be really hard to test all those different ways that you can actually represent it numerically to see what will work with your model. And it actually, will vary from the different models. Some representations work better with some models than others, right? AutoML really automates all that testing and pairs a lot of that up automatically for you.
Got it. So a few advantages I've been sort of picking out of what you've been saying, and some of them are sort of subtext, but like I've been in this field 30 years. I've produced either personally executed or overseen like literally hundreds of models. And I have the great advantage of having found what I like early on in my career. So I probably can run a dozen different techniques really well. And then there's some that, like, oh gosh, I haven't done a multi-chain Monte Carlo in forever, but I can pull it off, but most people don't have that in their toolbox, right? They can only do 2 or 3 different types of models. From what you're saying, it sounds like one of the big advantages is that you've got many models. I mean, there are literally hundreds of models. Joe Hare talks about that at the very beginning of his multivariate data analysis book. And there are hundreds of different models. With an AutoML program, you have access to all that. It doesn't rely on the data scientist team to know how to run all those 100 from scratch. A second advantage that you mentioned is that it can iterate over and over again. And third is that there is a time component where it's very fast. And then fourth, by moving that sort of, not that it's getting rid of it, but it's reducing the amount of human intervention. It allows you to focus on some of the other more important things.
Yep.
It sounds like two potential disadvantages might be that you really got to watch the context, because again, it's a machine and it's just looking at numerical relationships. It's not looking at context.
Right.
So if it doesn't make sense, or there's not some sort of, theory underlying it, or any kind of framework that is going on, it's not going to know that. And a second potential disadvantage is your data's got to really be good, because if you're manually stumbling through something and you're like, oh, that looks weird, then you would have the intuition to go, oh, there's something, I need to fix that field. You know what I mean? Whereas an AutoML may not see that, and it would take a real expert to be able to see it at the end of the road instead of like through the process. So maybe those are light disadvantages, but I think AutoML is like the way we're going to go, right? I mean,
Oh, I agree. And actually, I agree with everything you said, except I actually think that AutoML makes it easier to spot data issues, not harder.
Okay.
So, to your point, you do have to have, data in some kind of format, which is actually true. This isn't actually a knock on AutoML. This is true of every algorithm, right? If you go into scikit-learn, you have to have your data in a certain format before you feed it in.
Right.
Right. So, this isn't a differentiator, between AutoML and anything else that we tend to use, any other tools we tend to use. But with AutoML, actually, I can, throw a data set in as long as I've got it in that, format. It doesn't have to be perfectly clean. Like, it can have all kinds of missing stuff. It can have even ill-formatted things. It's going to spot it really quick. It's going to tell me. Leakage, right, is a common problem. And that's a tricky one to detect. AutoML makes leakage a lot easier to detect, right? I can throw a data set in, really quickly figure out, I just built a model on it and it took me all of maybe 20 minutes, 30 minutes. And my results are actually ridiculously good.
Yeah.
Like ridiculously good. Or it's going to flag it up front and say, hey, you might have leakage here. It's going to catch a lot of that up front. Or if it doesn't, I can see it in the performance of the model very quickly.
Right.
Kick it back out and say, hey, let's talk about this data again. It's really great if you're not the ultimate subject matter expert on your domain, right? And I've actually, I've put this into practice, right? We meet with customers across all different kinds of industries all the time. I've had to come into lots of industries where I don't know a lot about how they actually go about doing things, right? What I understand a lot about is building models and interpreting the results, right? But just from that and just doing it very quickly with AutoML, I can say, hey, there's an issue here. I'm not sure where it's coming from, but I know it's here. Yeah. Let's talk through that. And that really helps drive the conversation forward, which really helps to push the value, getting to the value much more quickly. Right. Are there
wrong ways to use AutoML? Would you say that there's wrong ways or wrong? Yeah. It's a leading question. I mean.
Yeah, absolutely.
Yeah. Let's talk through those. And then, because what I'm trying to get at is, what is the right way to do it? Because I see so many people that just want the easy button. And they just want to push the button and walk away and not look what's in the black box. And so talk us through some of the, with great power comes great responsibility.
Absolutely. Yeah. It's like it's not a set it and forget it kind of thing. And none of the tools that we have in data science are. But maybe this is far enough along now that it's starting to bump up against some of that, right? You can't do that, right? You need to have at least one of two things: either really good domain expertise and understanding your data generating process, or a really good understanding of the modeling process and what goes into that. So you need, and if you have both, that's great, but you need at least one of those two things to leverage AutoML well. Like any powerful tool, right? It can have really powerful downsides if you don't pay attention to what you're doing and don't understand what you're doing.
So how would you recommend, so how do people get more comfortable? Like, how do they get that right blend?
I think,
in other words, if you came straight out of school and you went straight into AutoML, That's going to be different than kind of my generation, where you did things manually and then AutoML came around and you're like, oh, this is great. All these things I've been doing manually, I can now expedite them. You see what I mean? Like it's a new generation. So they've never been through the manual process.
Absolutely.
Just like to give you a quick example, one of the very first classes I taught was at Berry College, and it was an applied statistics class. And believe it or not, I made people calculate standard deviation by hand.
Yep.
And they thought I was insane for making them do that. But if you don't do things like that, then when you ask them, what are you standardly deviating from? They have no idea. But if they've gone through the math and they do it, then they understand like, oh, well, now I know what standard deviation means because I went through the math and did that. So how are we managing what's really going on under the hood? Are we just expecting people to trust now? Because if they didn't grow up that way, they grew up in a DataRobot kind of generation or an AutoML kind of generation. Do you see what I'm saying?
Yeah, oh, absolutely. Yeah. Shout out to one of my professors, Bill Swallow, who actually made me do ANOVA
yes,
by hand.
I've done it by hand.
Yeah,
absolutely.
yeah.
Love it.
There is value in that. And I think there's ultimately pedagogical value in that. Right. And I would say that, and I actually feel like, that's my generation as well. But I also went back to school later and got my degree, and then literally went to work at DataRobot, like got my master's and went to work at DataRobot. So I've experienced the other end of that as well. And I think that as long as you've done a lot of model building, or if you go and do a lot of model building, it's still okay. You're going to have that same set it and forget it opportunity with scikit-learn that you're going to have with an AutoML tool.
Sure.
Any of them, right?
Right.
Because it's just another layer of abstraction at the end of the day. And so I think what you're going to want to do is, go educate yourself, like go understand, go work on a whole bunch of problems, go really, get your hands dirty, with it. Talk to somebody that already has gone that path and ask them about the pitfalls, right? Like you still need to go out and practice your trade and your craft, just like anything else. And, 15 years ago, that was like understanding what SAS was doing under the hood.
Right.
Right. And understanding your data generating process and talking to the business experts. It's not any different now, right? It's just, there's a little bit more automation that's going on.
Right. Okay. What do you think the future holds? Like, is this it? I mean, I think knowledge graphs are definitely a part of the future, and graph analytics, and ML is just, we're not even going to talk about ML anymore. It's just, that's the way we're going to do data science, is machine learning. But is AutoML, this is it? This is how it's going to be in the future? Like, what do you think the future holds for the application of automated machine learning?
Yeah, another great question. I think the only prediction that I'm 100% confident about is that not 100% of my predictions are going to be right. Most of them are going to be wrong, right? But I do think this is part of the next step, the next evolution, right? It could be, this is speculative, but eventually, you may have like DataRobot GPT instead of like the Chat GPT that just came out, where you type in what you want to do and it does it. But guess what? Even if you did that, like you still need to understand your data generating process, your business process, focus on value creation. You still need to know all that, right? You still need to understand that when the results come out, like, are they good or not?
Right. I do think that in some ways we're going to have a harder challenge getting people to understand what's in the black box. I mean, they can open that box anytime they want. People talk about the black box. Yeah. It's openable. You can take the black part off and make it transparent and see anything you want. But do you think we're going to, by having more AutoML, are we influencing that in some ways? How do we get people to care about what's in the box? Well,
that's a tricky question. So like 120 years ago, right? Like people were wiring their houses themselves. If you go into some museums, you can even see homes, the wires are exposed and out and all that. Like there do have to be guardrails built in. A lot of AutoML tools are doing that. At some point, data, models, predictions, all that has to flow like electricity and be similarly safe like electricity. And so there's going to be some level of abstraction that we all get comfortable with and eventually just move forward.
Oh, gotcha.
Because it'll just work.
Right.
But then there's also some level of like, oh, hey, you're changing out your switches there turn off your electricity,
Yeah.
right? That people will still have to have.
Love it. Love it. What final piece of advice would you give, Chad, for people wanting to successfully leverage AutoML to solve problems?
Yeah, I would say get started. Like that is the number one piece of advice. Get out there, get started. Right now, don't go use AutoML and then run to your business leaders and be like, "Yeah, I solved this. Solve this problem." Make sure you understand the problem and focus on the value creation. Right? Again, just another level of abstraction, which has its benefits that allow you to focus more on the value creation. Right? Go out there, use it, try to understand what's going on, leverage experts, right? Go out. I mean, we're still not at a place where you don't need some experts. Go out and find a data scientist if you're not one. And if you are a data scientist, great. Like it's going to make your life so much easier. Go out and build. You said you built hundreds of models.
Yeah.
I've built thousands in the last year.
Wow.
Right. Go out and build thousands of models. Build 10,000 models. You're going to do it in no time.
Yeah.
Flat.
Yeah. Excellent. Wonderful. Thank you so much to Chad Harness, Director of Technical Enablement at DataRobot, for talking to us about successfully leveraging AutoML.
Thank you, Beverly. Thank you very much.